Wherever there's a celebration, be it the New Year's Eve, a birthday bash, or a wedding extravaganza, fireworks take center stage. But have you ever paused to think about the magic behind those stunning bursts of color? How are they made? Who was the brain behind this invention? At their core, fireworks are a fascinating blend of chemistry and engineering, and of course a lucrative market. In terms of revenue, the global fireworks market size was valued at around $2.6 billion in revenue in 2023 and has stayed above that mark since then. Eager to know more? Join us as we explore how they are made in the factory, their secret ingredients, and what makes them light up our celebrations. Do you know that the first fireworks were made from simple materials like paper and bamboo tubes? Well, that's what it was before the advent of technology. Fireworks were first made in China from paper and bamboo tubes filled with finely ground charcoal and sulfur. That was about 2,000 years ago. When ignited, these tubes produced a flash of fire and smoke, but no explosion. True fireworks did not exist until saltpeter was added to the mixture to create a black powder 1,000 years later. Black powder was probably first made in China, but some scholars suggest that the Arabs may have invented it. The Chinese used black powder for fireworks, signals, and weapons such as bombs and rockets. However, black powder was introduced to Europe in the 14th century as an explosive for fireworks and guns. By the late 17th century, it was applied to mining and road building projects. Black powder was used for gunpowder until it was replaced by nitrocellulose in the late 19th century and dynamite for industrial purposes in the early 20th century. However, it is still used in fireworks today. Fireworks back then started as simple firecrackers designed to ward off evil spirits and celebrate festivals. Over time, their development continued, culminating in the breathtaking displays seen by European explorers during the 16th century. When fireworks reached Europe, they were initially fashioned from military explosives. These explosives were reimagined for festive occasions, primarily to celebrate military victories. This transformation paved the way for the beautiful fireworks shows created by Italian pyrotechnicians in the following centuries. Now, you might be asking yourself what pyrotechnics means. Simply put, it refers to the science and art of using fireworks in displays. This knowledge is crucial for crafting spectacular shows that captivate audiences. Today, many of the largest fireworks companies in the United States are owned and operated by Italian-American families, a testament to the rich heritage of pyrotechnics in Italy. The Italian style of fireworks was often showcased on elaborately decorated wooden platforms, sometimes set on water. This not only ensured safety, but also created a beautiful reflection of the colorful explosions. In contrast, German fireworks of the era were typically shot high into the sky, resembling the iconic displays we see today. Although the firework displays of the Italian masters were extremely complex and impressive works of art, the technology of the time limited their color and brightness. During the 19th century, the introduction of aluminum and magnesium greatly increased the brightness, while the development of potassium chlorate by the French chemist Claude-Louis Berthollet, who was trying to improve the gunpowder used by Napoleon's troops, made it possible to produce more intense colors. Today, fireworks are made all over the world, but more in Europe, Latin America, the United States, and Japan. Before diving into the major materials used to make a firework, let's understand the concept of pyrotechnics. Understanding the meaning of this keyword is really important because we can't elaborate on how fireworks are made without mentioning pyrotechnics. Pyrotechnics is derived from two Greek words, pyre, which means fire, and technikos, which means made by art. Therefore, pyrotechnics is the science of creating exothermic reactions to create sound, smoke, gas, light, or heat. It is used to create fireworks, parts of automotive airbags, oxygen candles, explosive bolts, and gas pressure blasting in quarrying and mining, among other things. Now, let's see the materials used to create fireworks in factories. A modern firework consists of a shell of plastic, papier-mâché, or heavy paper surrounding compartments separated by cardboard. A small compartment at the base of the shell contains black powder, which propels the firework into the sky from a mortar made of iron, aluminum, plastic, or heavy cardboard. A larger compartment contains chunks of a mixture of chemicals that produce light and color when heated. These chunks are known as stars. These stars are essential components of fireworks, designed to unleash vibrant light and color when heated. In American and European fireworks, these stars are blended with black powder, all contained within a cylindrical chamber. When the black powder ignites in an explosive burst, it triggers the stars, sending them soaring into the night sky in a spectacular display. In contrast, Asian fireworks take a different approach. Here, the stars envelop the black powder in a spherical compartment, resulting in a more balanced and symmetrical presentation of light. But fireworks can create more than just colorful bursts. Some factories use flash powder instead of traditional black powder and stars. This combination brings about an instantaneous bright flash and a resounding bang, adding another layer of excitement to the show. The fuses that connect these various compartments are cleverly constructed from threads laced with grains of gunpowder, ensuring that each element ignites at just the right moment. We've mentioned black powder a couple of times. You might be wondering, what's that? Black powder is a precise concoction made of 75% saltpeter, potassium nitrate, 15% charcoal, and 10% sulfur by weight. On the other hand, flash powder is a more complex mix that includes potassium chlorate, perchlorate, sulfur, and aluminum. As for the stars, they are crafted from a fuel that ignites to generate heat, a coloring agent that brings color to life, and an oxidizer to sustain the burning process. The choice of fuel can greatly influence the display. Slow-burning fuels like charcoal or red gum create gentle, lengthy shows, while fast-burning fuels like aluminum or magnesium generate brief but dazzling explosions. Sugar can also be used as a fuel to create smoke in fireworks. As for the colors in fireworks, they come from various agents: aluminum, magnesium, or titanium for white, carbon or iron for orange, sodium compounds for yellow, copper compounds for blue, strontium carbonate for red, and barium nitrate or barium chlorate for green. Oxidizers like potassium perchlorate and ammonium perchlorate are crucial too. These oxidizers are reactive compounds that contain oxygen and chlorine, which react with the coloring agents to create unstable chlorides that produce vibrant colors. Now let's explore how these fireworks are made step by step. Let's get started. Step 1. Designing the fireworks. This stage sounds simple but crucial. Technicians need to have a structure before creating the fireworks. They get this by crafting a design that includes the color, size, and effects once ignited. This determines the chemicals and materials used for the final product. Step 2. Making the stars. The ingredients used to prepare stars are obtained from chemical supply companies and stored in barrels. When mixing, the chemicals are scooped out of the barrels, weighed and sifted twice through brass screens to remove lumps. Brass is used because it doesn't produce sparks. The sifted powders are placed on a large sheet of paper and gently mixed by hand. The powders may also be mixed inside a rotating drum or a stationary container with rotating paddles. These devices must be used carefully to avoid generating heat through friction or trapping bits of powder between moving parts. The mixed powder is placed in barrels and taken from the mixing room to the cutting room. Water is mixed with it to form a soft dough. Lumps of the dough are scooped into large, paper-lined wooden molds shaped like loaves of bread. A wooden mallet packs the dough firmly into the mold. The loaves of dough, weighing about 35 pounds, 16 kg each, are unmolded onto a workbench covered with heavy cardboard sprinkled with black powder. The loaves are cut in one direction to form slices, and then cut in the other direction to form dice, which may be 0.06 to 2 inches in diameter. The black powder adheres to the wet dice and helps them burn when the firework is ignited. The dice are allowed to dry on paper-covered screens. The dried dice are now stars. They are moved to the packing room and placed into cardboard containers. A hollow cardboard tube is placed in the center of the cylindrical container, and stars are gently poured around it. A large container may hold as many as 900 stars. When the container is full, black powder is poured inside the hollow tube and removed. The powder fills the spaces between the stars, igniting and scattering them. The next step is the shell and the breaks. How are they made? Let's find out. Step 3. Moving stars into breaks. Each explosion you see in the sky is called a break. Thus, you can have many breaks within a shell, depending on the number determined by the manufacturer. To make the break, the worker picks what looks like a paper cap and fills it with stars. It is then wrapped with heavy string, a process known as spiking. Spiking involves tying one end of a large spool of string to the break and winding the string around it. When the break is completely covered, the string is cut and tied. Some breaks are not spiked, but made of plastic or heavier cardboard to withstand the stress of being launched. A time fuse, a short, slow-burning fuse that causes the break to explode a certain amount of time after it is launched, is inserted into the break and then wrapped in heavy paper. The wrapped breaks are then moved to the pasting room to be wrapped in heavy paste-soaked paper, which is allowed to dry for about 2 days. The paper hardens as the paste dries, forming a strong, tight seal. Some breaks, known as salutes, are filled with flash powder rather than stars and black powder. Flash powder is mixed in the same way as the chemicals used to make stars. It is then poured into cardboard containers that are thicker and stronger than other breaks. This allows more pressure to build up before the salute bursts, resulting in a louder bang. These salutes are then spiked and pasted like other breaks. Step 4. Dry breaks are moved to the finishing room and assembled into shells. This container holds the stars and other components that will be launched into the air to create effects. The simplest shells consist of a small compartment of black powder combined with a single break. Due to their spherical structure, Asian shells always contain only one break. Because American and European shells are cylindrical, more than one break can be stacked together, causing the shell to display multiple bursts of different colors when it explodes. Multi-break shells usually consist of a small compartment of black powder, 3 or 4 colored breaks, and a salute. Some large shells contain as many as 10 breaks. Once in a while, one gigantic shell can hold 22 breaks. The shell is assembled by stacking the components together, attaching a starting fuse, a long, fast-burning fuse used to ignite the black powder that launches the firework, wrapping them in heavy paper, and tying the package together with string. Step 5. Assembling. All parts are connected securely and well sealed to prevent accidental ignitions. The completed firework is then labeled and stored. Step 6. Quality control. So at this point, a few samples of the fireworks are tested for quality control. This is to ensure they function properly. Thereafter, they are packed with protective material and labeled with clear safety instructions, ready to be transported to the stores and picked up for a dazzling display. Step 7. Packaging. Let's take a look at how they are packaged in the factory. And now that we've seen how fireworks are made in factories, do you know you make simple fireworks at home as well? But first, you need to know that safety is the most important factor when it comes to fireworks. Firework factories are protected from intruders by chain link fences, barbed wire, locked gates, steel doors, and tamper-proof locks. Within these factories, numerous precautions are taken to prevent accidents. Electricity is the greatest danger. A single small spark can set off a room full of explosives. All electrical outlets are located outside the building. All workers must wear 100% cotton clothing to avoid generating static electricity. They touch a copper plate before entering a building to remove any static electricity they may carry. Elastic straps with wires trailing to the graphite floor are worn around the workers' calves to drain static electricity away to grounding rods buried beneath the building. All work is halted and all workers leave the building if there is any possibility of an electrical storm approaching. Many other safety measures are used. All work is done by hand to avoid machines that could produce heat or sparks. In the winter, buildings are heated with hot water rather than hot air, which could cause an explosion. The buildings are small, so no one is more than 1 or 2 steps away from an exit. All exits have doors that open wide at the slightest touch. Explosive chemicals are never mixed when wet because they may release gases that could ignite them when they dry out. As for fireworks testing, professionals set them off in secluded areas to know how functional they are. Aside from the factory style of making fireworks, do you know you can make fireworks at home? Those skybound explosives are not something you can DIY your way through. There's some exciting fiery fun you can create right in your backyard. And what's more, we're walking you through everything you need to know. To make sparkles, you will need 300 grams of potassium chlorate, 60 grams of aluminum files or shavings, 2 grams of charcoal, 1 teaspoon of dextrin, and 9 teaspoons of water. You will also need 5 grams of strontium nitrate, optional for red color, and 60 grams of barium nitrate, optional for green color. So how do we make sparklers? First, mix potassium chlorate, aluminum files or shavings, and charcoal in a bowl. Pour the dry ingredients, 3 grams of potassium chlorate, 60 grams of aluminum files or shavings, and 2 grams of charcoal into the bowl. Use a spoon to mix the powders until they're evenly distributed. Break apart clumps that form in the powder so the ingredients mix thoroughly. Then mix 1 teaspoon of dextrin with 9 teaspoons of water in a cup. Add a small amount of the solution to the dry mixture. Continue adding the water and dextrin in small increments until the bowl's contents become gooey, like molasses. Without any additional ingredients, the sparklers will burn white. If you'd prefer red sparklers, weigh 500 grams of strontium nitrate on your digital scale and add it to your mixture. If adding the strontium nitrate makes the mixture too dry, add a pinch of your water dextrin solution to regain a goopy texture. Instead of adding strontium nitrate to create red sparklers, you can use a smaller portion of barium nitrate to create green ones. After precisely weighing 60 grams of barium nitrate with your scale, pour it into the mixture and mix it thoroughly. Be sure to mix the ingredients well so they are evenly distributed. Again, add more water and dextrin if the mixture gets too dry. Dip wires or sticks into the mixture, leaving room at the end for gripping. You can use stiff wire or wooden sticks to make the sparkler handles. Dip each handle into the mixture and slowly pull it out so that the top 2/3 of each stick is completely covered by the mixture on all sides. Leave the bottom third uncovered to have enough room to hold your stick. 10 inches is a good length for a stick and the common length for kebab skewers. Leave at least 4 inches at the bottom for a handle. Ignite the sparkler by putting the covered end into a flame. Hold the uncovered end of the stick or wire as the handle. Place the opposite end of the sparkler into an open flame and wait for the mixture to ignite. The next one is glow snakes. To create your glowing snakes, you need sand, high-proof alcohol, 1.5 grams of sugar, and 0.375 grams of baking soda. Pour 1.5 grams of powdered sugar into a medium-sized bowl that will be easy to stir. Before you proceed, make sure you're using powdered white sugar. If you don't have powdered sugar, you can grind up table sugar in a coffee grinder. Then, mix the measured baking soda with the powdered sugar. Use a spoon to thoroughly mix the sugar and baking soda before moving on to the next step. Thereafter, make a mound of sand on the plate and push a depression into the middle. It doesn't matter exactly how much sand you use. Just pour enough to create a small mound on your plate or baking sheet. Then, press your index finger into the top of the mound to create the depression. Once you're finished, the mound will look like a donut. This depression should be deep enough to hold your mixture and allow for proper ignition. The next step involves wetting the sand, which you should do using high-proof alcohol. Specifically, you want to select alcohol that is at least 80 proof or higher for the best results. The reason for this is straightforward. The higher the proof, the easier it will catch fire. Pour the alcohol onto the sand carefully, ensuring you don't drench it to the point where it loses shape. Generally, aiming for about 1 tablespoon of alcohol for every cup of sand will work well. After you've coated the sand, take your prepared mixture of baking soda and sugar and fill the depression you've created. There's no need for precise measurements here. Just make sure the hole is filled adequately. Once everything is set, it's crucial to refrain from adding any more alcohol after the snake is lit. Introducing more at that point can create a risky situation where you could accidentally set the alcohol bottle ablaze. To ignite your glowing snake, use a match or a lighter to touch the flame to the alcohol-soaked sand. The sand will ignite first, which will then cause the glowing snake to expand and come to life with a bright, fiery display. Remember to keep any flammable materials at a safe distance during this process. Step away from the glowing snake as soon as it's lit. Be careful where you light the glow snake. As it expands, it may grow larger than the plate you put it on. Now, here's the last. You need 128 grams of sugar and 192 grams of potassium nitrates to do this. So, how is it done? Create a mold out of aluminum foil. To get this, wrap the bottom of a soda can in the aluminum foil and then remove the soda can. The foil will hold the shape. Shape the aluminum foil so the opening faces up, then set the mold aside. Pour 128 grams of white granulated sugar into a skillet. Measure the sugar using a dry measuring cup to ensure you have the correct amount. Pour it into a standard size 12 skillet, but don't turn the heat on yet. Do not use a measuring cup for fluids, as the measurements will differ. Add 192 grams of potassium nitrate. Pour the potassium nitrate into the sugar. Use a wooden spoon to mix the two powders until they are well blended. Make sure the ingredients are mixed thoroughly for the best results. Spread the mixture out evenly in the pan once it's thoroughly mixed. Apply low heat to the pan while you stir the mixture with a spoon. Place the pan on the stove with the burner set to low and continue mixing the ingredients using long, slow strokes. Eventually, the sugar will begin to melt. Continue stirring the mixture as the sugar melts and mixes with the potassium nitrate. You'll probably notice it caramelize and turn brown. Then, when the mixture liquefies, remove it from the heat. The two will form a liquid sludge as the sugar melts and mixes with the potassium nitrate. Once liquid enough to roll around the pan, turn off the burner and remove it from the heat source. Keep stirring the mixture as you remove it from the heat. For this bit, you'll need to move quickly. The mixture will start hardening soon after it is removed from the heat, and you need to get it into your mold before it does. Then pour the liquid mixture into the foil mold. Be careful not to spill any of the mixture as you do this. Once there's a thick layer of the mixture on the bottom of the mold, it can be any depth you choose. Set the remaining mixture aside. If there's enough left over, you can always make another smoke bomb. Don't touch the foil once the mixture is inside because it will be hot. Allow the smoke bomb to cool overnight, then remove it from the foil. Leave the mixture in the foil overnight, and the next morning, peel it off the smoke bomb. The smoke bomb itself is entirely flammable, so there's no need for a fuse. Do not ignite the smoke bomb indoors or breathe in the smoke it produces when lit. Be extremely careful when lighting it, as it may produce more smoke than expected. Give yourself tons of open space. Ignite the smoke bomb by exposing it to a flame. There is no fuse on the smoke bomb. To set it off, ignite any portion of the mixture using a lighter or match, then set the bomb on the ground or another horizontal surface to burn. The smoke bomb may not burn with a visible flame, but it's still super important to keep it away from flammable things, just in case. And lastly, do not hold the smoke bomb while it burns. The homemade methods will help you build a firecracker that is not expensive. Which of these will you choose? Let us know in the comment section below. However, there is one more thing you need to know. Firecrackers might pose a threat to the society, but improper use of fireworks harms the person operating them, risks of burns and wounds, and bystanders. They may also start fires on landing. To prevent accidents, fireworks are legally restricted to professionals in many countries. Smaller consumer versions may or may not be available to the public. Hence, ensure you know your country's restrictions before purchasing or making a firecracker. So, how far have fireworks gone in different countries? Let's find out. Fireworks are a common feature in many popular celebrations. They add excitement and create a festive atmosphere. Events like New Year's Eve, Independence Day, and festivals worldwide often include fireworks displays. People gather to enjoy the colorful bursts in the sky, marking special occasions with light and sound. In Australia, fireworks displays are frequently used to celebrate public holidays, particularly New Year's Eve and Australia Day. The most famous is the Sydney New Year's Eve midnight. Fireworks. In the Northern Territory, Cracker Night is celebrated every 1st July on Territory Day, and residents are allowed to buy and use fireworks without a permit. Also, fireworks are an essential element of popular festivals in Catalonia, especially the patron saint day for each Catalan town or city, usually called Festa Major. Coet. Rocket is the generic term for all pyrotechnic devices. Professional aerial displays are less common than the use of ground-based fireworks by members of ritual crews. In France, fireworks are traditionally displayed on the eve of Bastille Day to commemorate the French Revolution and the storming of the Bastille on that same day in 1789. Every city in France lights up the sky for the occasion, with a special mention to Paris, which offers a spectacle around the Eiffel Tower. In Hungary, fireworks are used on 20th August, a national celebration day. During the summer in Japan, fireworks festivals are held nearly every day someplace in the country, numbering more than 200 during August alone. The festivals consist of large fireworks shows, the largest of which use between 100,000 and 120,000 rounds, and can attract more than 800,000 spectators. Street vendors set up stalls to sell various drinks and staple Japanese food, such as yakisoba, okonomiyaki, takoyaki, kakigori, shaved ice, and traditionally held festival games, such as Kingyo Sukui or goldfish scooping. Even today, men and women attend these events wearing the traditional yukata, summer kimono, or jinbei, and gather in large social circles of family or friends to sit picnic-like, eating and drinking while watching the show. The first fireworks festival in Japan was held in 1733 when Tokugawa Yoshimune, the 8th shogun of the Edo period, decreed that a festival be held on the Sumida River on July 9th every year to mourn those who died in famine and other disasters. This event is recognized as the start of the Sumidagawa Fireworks Festival, which is one of Japan's most recognizable fireworks festivals. What about America? The earliest settlers brought their enthusiasm for fireworks to the United States. They were used to celebrate important events long before the American Revolutionary War. In 1789, George Washington's inauguration was accompanied by a fireworks display. This early fascination with fireworks noise and color continues today, with fireworks displays commonly included in Independence Day celebrations. In 2004, Disneyland in Anaheim, California pioneered the commercial use of aerial fireworks launched with compressed air rather than gunpowder. The display shell explodes in the air using an electronic timer. The advantages of compressed air launch are reduced fumes and much greater accuracy in height and timing. The Walt Disney Company is now the world's largest fireworks consumer. We are moving closer to the beginning of a new year. Traditionally, fireworks are released to signify the beginning of a glorious year. When you see the lights in the air, remember the process it went through. Don't be afraid to light one. However, always remember that safety comes first. What can you say about fireworks production? Feel free to air your views in the comment section below. Remember to hit the like button and subscribe. Before you go, click on the video displayed on your screen.